Hey, Algebra 2 students. So I'm going to do out a video version of the answer key to the study guide or the review for our transformations of functions quiz. That is next week. If you're A day, it's going to be on Monday. If you're B day, it's going to be on Tuesday. So feel free to watch this to help you study this weekend and understand more in depth the answers to this review. So the first problem here is to base your answers on the graph of the parent function below. So basically, you really just need to be able to kind of commit this stuff to memory for the parent functions. So when you see this graph, you should automatically know, oops, I'm annotating, don't want to do that. So when you see this graph, no matter if it is in this direction or if it would be in this direction, this one wouldn't be the parent one, the one that I gave you was. So this would be the cubic function, and that's the name of it. The equation of the cubic function is y equals x to the third. The domain of this and all cubic functions is negative infinity to infinity. No matter if there are transformations or not, that is always the domain and the range. And the reason for that is this graph extends forever in both directions. So it's going to go up and down forever and continue out left and right forever. So always negative infinity to infinity for cubic. The next one here, this should be one that you are most familiar with. This is a quadratic. The U shape is always quadratic. And anything with this shape of a graph is y equals x to the second. That is the parent function for quadratics. The domain for all quadratics, no matter what, even if there are transformations, is negative infinity to infinity. The range can change for the quadratic graph depending if you shift up or down. But this one, oh no, I'm gonna have to retype all that. Sorry about that, guys. So negative infinity to infinity. And like I was saying, the range here, so if you have a vertical shift, it will change the range. If not, my range is my lowest y value here, which is 0. And then this is going to go up forever, so towards infinity. So this is going to be 0 to infinity, including 0. So that would be my range. Here I have the square root function. So anytime I see a graph like this, I know it's a square root function. The square root function, it doesn't have negative x's because you can't take the square root of a negative number. So this is y equals square root x. If you need to find the square root, you can either just type SQ RT and it will come up, or you can type it in the keyboard down here. The domain of the square root function, it starts at 0 and heads out to infinity. I don't have any negative numbers here, so it doesn't make sense to have negatives, and same with the range. And the square root function is the one where the domain and range both change pretty constantly. Horizontal shifts, reflections will all change domain and range for square root function. Whenever I see a v, this is the absolute value function. The equation of the absolute value function is y equals absolute value of x. The domain is very similar. The absolute value function is very similar to quadratic. It's negative infinity to infinity, no matter what. And the range, same as quadratic, 0, infinity. And that will change based on if you have vertical and horizontal shifts. Sorry, just vertical shifts, not horizontal shifts. We have one more function. It would be the linear function, but we don't worry too much about linear functions. So here it says state the parent function, describe the transformations, complete the table, the graph, the function, graph of function. I don't know why these directions are here because I don't have you do that in this problem. Copy and paste error, my bad. So here you're just going to state the equation of the parent, the transformations, and then domain and range. So here, compared to the parent function, which is x squared, I have two additional pieces of information. I have this 3 here on the outside, out in front being multiplied. And then I also have this -4. Each of these are a different transformation. So the 3 on the outside, that tells me that A equals 3. And we should know that when A is greater than 1, it's going to be a vertical stretch. And remember, stretch refers to, when we're talking about vertical, it refers to the length of the function. So we're stretching and we're pulling it up. So it will get skinnier, but we're stretching the length of it. We're stretching the y values. -4 out here on the outside in orange is my vertical shift down 4 units. So this is going to get skinny and then it's going to scoot itself down. So actually, let's take a look at that. So if I pull up my Desmos graphing calculator. Then I type in my function. So it's scooted down, and I can compare it to the parent function here. So it's scooted down 4 units, and then notice the red one got skinnier, but it's vertically, it's gotten longer. So vertical stretch. So here I can talk about domain and range. Domain of a quadratic function never changes. It's always -infinity to infinity. The range, however, here, the range did change. I now have a lowest y value of -4. So this graph is going to go from -4 up forever to infinity. So this will be -4 to infinity. Let's look at another one. So here, this is going to be an absolute value. My transformations, remember, each different thing compared to the square root or the parent function is a transformation. So the negative is its own transformation, the 5 is its own transformation, and the +3 is its own transformation. When there is a negative out front, that is a reflection over the x-axis because you are multiplying by -1. The 5 is my A value. So here we have A equal to 5, not -5. We've already talked about the negative. So A is 5, which means A is greater than 1. So again, we have a vertical stretch by a factor of 5. And then the +3 is my vertical shift up 3 units. So if I go ahead and put that into my Desmos here, I'm going to have -5. I'm going to find the absolute value of x +3. And I'm comparing that to just the regular absolute value function. So again, just like quadratics, my domain and range never change for absolute value. They're always -infinity to infinity. I'm sorry, just the domain, not the range. I shouldn't be doing this video at 8:45 at night, but you know, we're going to get through it. So the domain never changes for absolute value or quadratics. It's always going to go -infinity to infinity. But my range here this time, my graph is upside down. And when I talk about range, I talk about my range from lower bound to upper bound. So I look at this graph from the bottom to the top of it. And the top of my graph is right here. And at that point, my y value is 3. So here my range is going to stop at y equals 3. And it's going to start, well, if I zoom out here, this graph has I mean, I'm pretty zoomed out, and look at all those y values. Negative 50,000. That's pretty intense. So I'm going to say that this range is from negative infinity to 4. I'm sorry, to 3. It doesn't go past 3. Look, 3 is still my highest y value. It's hard to tell from really far out, but 3 is my highest y value. There's nothing above that. So negative infinity to 3. Negative infinity is a very small number, so it comes first. We write smallest to largest. Here we have a cubic, so we have x to the third. I have a negative out in front, so that's my reflection over the x-axis. I have a -3 here inside my parentheses happening directly to my x. So this is going to be a horizontal shift to the right 3 units. It's to the right because when we're directly next to the x, we're going to do the opposite. And then I have my +2. So this is my vertical shift up 2 units. I don't have to look at the graph here for the domain and range because for every single cubic function, it's negative infinity to infinity. My computer's pausing. So negative infinity to infinity for my domain and range. Always, always, always for cubic functions. I have a square root function here. I have a 1/5 on the outside. So that is a. That is my a value. My a is 1/5. That is between 0 and 1. When a is between 0 and 1, that tells me that my transformation is going to be a vertical shrink. So what's happening here is they're pushing the graph down, and it's getting wider, yes, but it's shrinking vertically. They're smushing it. So vertical shrink by a factor of 1/5. And I'm sitting over here like moving my arms as if you can see me, but you can't. But it's a vertical shrink by a factor of 1/5. So they're smushing it down. Oops, I forgot to type in my parent function, which is square root. I then have a negative on the inside of my square root. When I have a negative on the inside, it is a reflection over the y-axis because I'm taking my x values and I'm making them negative, which will flip it over the y-axis. And then -7 all the way here on the end is my shift down, my vertical shift down 7 units. Look how I'm being so specific here. You should do the same. So my domain and range here is the one that I really need to look at the graph for. Square root function I find to be the most challenging if you don't have a graph. So I'm going to look at my graph and I'm going to compare it to the original. See, the original here was, we know it's 0 to infinity and 0 to infinity. But this time, my y values start at -7. And if I zoom in here, they start at -7, but we're talking about the y value. So we're going to talk about the range first. As my graph goes out, right? So my graph is going out this way. My y values are increasing, right? My graph is going to keep increasing. My y values are going to keep going up and up and up, right? So as it continues this way, if I look at the values for y, they just keep moving up. So this range is going to go from -7 to infinity. Plus, I don't have any values below -7, right? Nothing, I don't have any y values below this point, so it can't be anything down there. For x values, I have all negative x values, and then I stop at -7. I'm sorry, I stop at x equals 0. So my domain is going to be negative infinity, comma 0. Again, I don't have any positive x values here. There's nothing past this 0. No positives. So it has to be negative infinity to 0. One more with absolute value. So I have a 2 out in front here. This 2, since it is my a value, and a is bigger than 1, then we are going to stretch the graph, make it so that it is skinnier, but it's longer. So this is a vertical stretch by a factor of 2. And then I have a plus 1 on the inside of my function. The plus 1 on the inside is a horizontal shift left 1 unit. And then minus 6 on the outside is my vertical shift, and we're going to go down 6 units. For absolute value, domain never changes. It's always negative infinity to infinity. And I can look at the graph to determine the range. And I can compare this graph to the regular absolute value. And you can see here that it is skinnier. It's shifted over this way and shifted down. So this range is going to be from my lowest y value here is this negative 6. So I'm going to go from negative 6 and then I'm going to shoot up. So negative 6 to infinity. Make sure you're using your proper brackets here. So you're using these square brackets on any value except for infinity. Another quadratic here. I have 2 separate things, 2 additional pieces compared to my parent function, which is x squared. I have a negative out in front and I have a 1/3 unrelated to one another. Each of them are their own transformation. So the negative is something and then the 1/3 is something else. The negative out front is my reflection over the x-axis. It's going to turn my graph upside down. And then when I have a 1/3, that is my vertical shrink, because it's my a value and it's between 0 and 1. My domain will never change. It's always negative infinity to infinity for all quadratics. The range is going to be different, so I'll look at the graph. And I can compare it to the original. Notice compared to the original, it is upside down. That is because of the negative out in front. That's what turned it upside down. And then it is wider, and that's because of the 1/3. So that's my reflection and my shrink. It's flattened it out. It's harder to see here because it's upside down, but this is gonna, again, bottom to top for my range. So if I zoom out here, there are tons of y values, negative y values for the red graph. The red graph doesn't go past 0 for the y's. So this is going to be negative infinity to 0. Remember, we come bottom to top. So we approach from the bottom. From the bottom, the lowest possible value that we can get close to is negative infinity. And then we come to the top, which is 0. All right, so now you're going to go in the opposite direction and you're going to write the equation itself. So you're going to add things onto your parent function. So here I have horizontal shift right 4. So it's going to go inside my absolute value bars. And since it's right 4, it's going to be minus. And then this says shift down 1. Because it is down, it's a vertical shift. It goes on the outside, so -1. For number 12, it's a vertical stretch by a factor of 3. So that means put a 3 on the outside. A reflection over the y-axis means multiply my x values by -1. So I'm going to make this the square root of -x. And then those are my only transformations there. There's no shifts, so I can't do anything else. For the last one, there's a couple of different transformations. Reflection over the x-axis means negative on the outside. Vertical shrink by a factor of 1/2 means 1/2 on the outside. Shifted left 3 units is going to be x plus 3. And this is of the squared function, so I'm going to raise this to the second power. And then I want to go up 7 units, so I'm going to add 7. There's a lot going on in that one, but if you take it step by step, it's not that challenging. Remember, each one of these just adds an additional piece of information onto your equation. Notice here the squared is on the outside of the +3, not on the inside. All right, so now we are going to kind of do similar stuff, but we're going to add a graph onto this. So my parent function is x squared because it's quadratic. There's a squared here. Transformations, there's a bunch. So there is a negative out in front here. That's going to be my reflection over the x-axis, which means the graph should be upside down. Then I have a 4 here. That tells me that that's my A value. That tells me that my graph is going to be skinny, which means they're going to stretch it. So this is going to be a vertical stretch by a factor of 4. Then I have my +3 on the inside attached to my x. So that is my horizontal shift to the left because it's plus 3 units. And last but not least, I have my -1 on the outside here. That is the last thing. That is my vertical shift down 1 unit because it is -1. That part doesn't seem to be too challenging. You guys really seem to be getting the transformations. The next part is where a lot of the mistakes come in evaluating this function. So I have my y equals, and I'm going to copy it down here. So we've got y equals -4 parentheses x plus 3 squared -1. And you really have to remember PEMDAS when you're doing this. PEMDAS is literally going to be in your math life forever. So you got to really remember it. And basically what it wants you to do, it wants you to take those values and plug them into the x here. So I'm going to click this little square root button. I'm going to copy and paste my equation. And I'm going to do x equals -4 first. So I'm going to put -4 for x. So then you get y equals, and I'm going to do my parentheses first because that's what PEMDAS says. So I get -1 squared -1. This is where people get lost. PEMDAS says do exponents next. So this becomes -4 times 1. If you don't believe me, pull up the calculator here. Right? Parentheses, -1, close parentheses, square it, comes out to be +1. And then I'm going to have y equals -4 minus 1, which is -5. So then I'm going to go to my graph. I'm going to plot the point -4, -5. That's a little off. Still off. There we go. Doesn't have to be perfect, but you know. So then I'm going to do this whole process again. Copy and paste is your friend if you're trying to save time during the quiz. And I'm going to make this a -3. -3 plus 3 is 0. 0 squared is 0. -4 times 0 is 0. 0 minus 1 is -1. So this is now the point -3, -1. I'm going to go over to -3 and down 1. Close enough. And then one more. So again, copy and paste is your friend. It makes this go a lot faster. So I'm going to make this -2 plus 3. -2 plus 3 is -1, or +1, excuse me. 1 squared is 1. That's going to be -4 minus 1, -5. And really, you should get repeats in your quadratic. Quadratics are symmetrical, so you should be able to fold them over itself, like draw a line down the middle and fold it over, and it should fall on top of itself. So here, this makes sense that I'm getting a -5 so that I can repeat my U shape here. Notice how this is fairly skinny. It is upside down. Good enough. It is upside down. It is skinny, so upside down, good. Skinny, good. Left 3, let's check that. 1, 2, 3. Yep, left 3 and down 1. So this graph does match my transformations. If it doesn't, it means you made a mistake in your calculations and you should check it out. There should be no mistake for your calculations because I am supplying you with a calculator. My domain here for all quadratics is -infinity to infinity. This graph, we go bottom to top. Since this is going down forever, it's going to come from -infinity. That is the smallest possible y value here, and it's going to stop at -1. And I can tell that right from my graph. I can also tell that from my table. That is the smallest y value, or sorry, the largest y value here. So all of that matches up. We have another one of these, this time with a square function. So I have a couple of transformations. I've got one on the outside here. This is a is 1/2. That is between 0 and 1. So this is going to be a shrink by a factor of 1/2. Then I have this negative on the inside of my square root. I'm multiplying my x values by -1, which is going to flip me over the y-axis. It's going to be a reflection over the y-axis. And then +4, as we should all be really comfortable with, is my vertical shift up 4 units. So then I'm going to use this equation to find out the x values here. To find out the y values. Copy and paste is your best friend here. So I'm going to copy and paste this in for x, and x alone. I'm not going to change anything else but the x. And when I do that, notice how I have a double negative underneath the square root. So many of you, when you do a problem like this, you say, Ms. Riziki, you can't take the square root of a negative number. Like, yeah, I know. That's why these numbers come out to be double negatives, which make it a positive. So again, keep simplifying. Take the square root here. This is why we learned GEMDAS. A square root is a grouping symbol. So this is going to be -1/2 times 4. Get rid of the square root of 16. Square root of 16 is 4. And then that's y equals 2 plus 4, which is 6. So I'm going to plot the point -16, 6. Then I'm going to do the same process for x equals 4. Guys, I know it's tedious to show all your work, but honestly, it's just tedious for the first one. If you use copy and paste, then it becomes much easier for the remainder. So I'm going to keep changing these. The square root of 4 is 2. 1/2 of 2 is 1. So this is going to be 5. So -4, 5. And then one more time for x equals 0. The more work you show, the more chance for partial credit. So this time we're going to put 0. There is no such thing as -0. It's just the square root of 0. Square root of 0 is 0. 1/2 of 0 is 0. So this is 4. So we plot the point 0, 4. And then we do our best to connect this. Mine doesn't look great, but it doesn't have to be perfect. That's what that looks like. Domain here. So we're coming from the left to the right. So I have no positives x values here. I have nothing there, no positive x's. So my domain is going to be -infinity to 0. My graph stops at x equals 0. It stops right here. So they're coming this way and they're stopping here. -infinity is smaller than 0. And then my range, bottom to top, well, the smallest y value of this graph is 4. There's nothing below that. And then it continues to increase, so to infinity. Here, there are some error analysis. So it says your friend got a question wrong on a quiz and is trying to correct their mistake. They've asked you for help. The question asked them to describe the transformation applied to the parent function square root x as shown in the equation. So this is the proper equation. And then it says their answer is shown below. So your friend says that this is shifted up 1, horizontal 2, and vertically shifted down 3. So this says select which parts are incorrect. Well, the 2 on the outside here, this is being multiplied by 2. This is my a value. So that's my shrink or my stretch. So horizontal shift right 2 units. That doesn't make any sense here. Also, because the horizontal shift here is right here, it's the +1, and that's a shift left 1, which also means that my vertical shift is not up 1. My vertical shift, the only part that your friend got right here was the -3. Sounds like your friend might need to come to extra help, which is totally fine. -3 means vertical shift down 3. So your friend did get that right, but the first two are incorrect. So it says explain why why it's incorrect, or / explain how you would correct your friend's work. So I would say the correction here is the out in front represents the a value of the function. And when a is larger than 2, or sorry, larger than 1, it represents a vertical stretch. So this should be a vertical stretch by a factor of 2. And then the other mistake is the +1 inside the square root or under the square root is shifting the x values. So it is a horizontal shift, and since it's +1, it is to the left 1 unit. So something like that to explain, why your friend's incorrect or what would be the correct answer is the best way to kind of go through this one. So here it says write a possible equation for the graph shown. So we know this is going to be quadratic because it is a U shape. It is right side up, so there are no, so here, let's make some notes here. So this is quadratic, so need some form of x squared in our equation. This is right side up, so not upside down, so no reflections. So no negatives out in front or on the inside. And then let's see, this is my regular quadratic that usually has a point at 0, 0. So this one, if I look at that, this was shifted over 2 to the left. So this was shifted to the left 2 and down by some amount. Let's see how far down it went. 1, 2, 3, 4, 5, 6, 7. Went down 7. Now I need to put those in an equation. So this is going to be x plus 2 in parentheses to represent my horizontal shift, and I'm going to square that, and then minus 7 on the outside. There are some other types of transformations that you could look at this, but it would make this complicated, so I'm not going to really talk about that. And one more here, I think. So this is the absolute value function because it's a v. This is upside down. So a reflection over the x-axis, which means we need a negative on the outside of our equation. And then there's no left or right shift, so no horizontal shift. But there is a vertical shift, and this shifted, if I look here, normally the point's at 0, 0. It's shifted up 2 units. So vertical shift up 2 units. So in my equation, I'm going to make this f of x equals the absolute value of, I mean my negative, or negative absolute value of x on the outside of the absolute value bars plus 2. And that is all for your quiz. So while you're correcting this, you should be making your correction. You should have made your corrections on paper. And if you have any questions, you can ask me for help. If you are in B Day, there is extra help on Monday at, I believe I said, maybe I said 2 o'clock. For this, if you are my A Day, the quiz is Monday during class. Make sure you are prepared. If you have any questions, let me know.